All right, so we are live, and I'm sitting with the guys who worked on the story research, and I would love to learn more, kind of in your own words, what exactly that means and what it is, and what kind of research you've done.
Yeah. Great. Thanks, Chad,
Cool.
for this interview. We're looking forward to it. So yeah, maybe we'll start with introductions, Arjun and Harsh.
Okay. So I'm Arjun. I'm a third year PhD student at Virginia Tech. My advisor at Virginia Tech is Devi Parikh, who heads the computer vision lab here. I also work with Mohit, who's on this call, and he works in natural language processing. My personal interest is to create AI agents that can interact naturally with humans. And my research involves teaching these agents some aspects of common sense and especially humor.
Hi, I'm Harsh. I was a master's student at Machine Learning and Perception Lab under Professor Dhruv Batra at Virginia Tech. In my 2 years as a grad student, I have been fortunate, I guess, to work on several interesting AI problems, ranging from low-level computer vision problems, like studying various object proposals, to like high-level multimodal tasks, like one of these projects. Whenever I'm not struggling to get my models to work, I think I contribute to open source tools that makes it easier for people to sort of understand AI and deep learning techniques.
Hi, I'm Mohit. So I was a grad student at Berkeley, and then I spent 3 years as a research faculty at TTI Chicago, which is part of U Chicago. And then that's where Arjun interned with me on this project that we're going to discuss, the short story project, and another fun humor-based project that we mentioned briefly. And now I'm an assistant professor at University of North Carolina, UNC Chapel Hill. So I work more on the natural language processing and machine learning aspects of things, but I do focus on multimodal, grounded, and embodied semantics, which in other words means connecting language to vision and speech for the applications of robotics. And then I also work on human-like language generation and dialogue models.
Cool, great. That's awesome. It's a wide range. I love that.
Yeah.
So tell me a little bit about the actual research that we're talking about today.
Yeah, right. So let's maybe start with what triggered it, right? So Arjun.
Yeah, I'd love to hear kind of like what brings up, how do you actually come up with this idea and say, okay, we're actually going to sit down and actually work on this? I think that it's a really interesting story all the time.
Right. So it's fairly natural. So Harsh and I were grad students at Virginia Tech, and we're essentially computer vision people. So in our lab, we work on things like scene understanding and generally problems at the intersection of vision and language. For example, we work on common sense. One example of a common sense related research project is from our lab, which tries to deal with understanding whether two sentences are paraphrases of each other. So the idea is you imagine the scene behind each of these sentences are similar, then there's a good chance that these sentences are actually paraphrases of each other. So visual common sense is an important research direction in our lab. So this project kind of fits in naturally.
Mm-hmm.
And right. We'll probably talk more about textual common sense.
So then I'm the other piece where, again, since I'm a natural language processing person who also focuses on the multimodal vision aspect, I think more from textual, temporal common sense angles. So for example, what hypothesis entails a premise, right? So if I'm walking in the rain, I get wet. If someone gets shot, hopefully not, then they get wounded. So these are known as entailment problems. I look at what are the coherent temporal structures that are involved in a discourse between people or a machine and a person, and in dialogue and conversation models, because that's very similar to telling stories, right? They have to have a structure, a beginning, a middle, and a climax. And it's also very important when you're trying to summarize multiple documents coming from different sources, because then you have to order them in a coherent fashion. So this is things that my group works on. And then we've also in the past worked on extracting and learning general common sense from the web for tasks like syntactic parsing, co-reference resolution, so determining who refers to what, inducing taxonomies like WordNet and so on. So this is the general background, and then Arjun will mention the actual anecdote of how this particular project came about.
Right. it literally started out as a class project for our spring semester computer vision course. So this was taught by my advisor, Devi Parikh. And so Harsh and I decided to do the class project together. So it's just sitting down and brainstorming ideas. And one of the things that we found really impressive was the results from automatic image captioning models. So these are models that, given an image, they describe what's in the image. And so these results were really impressive. But then the issue with this is that people don't really communicate with single images or single a sentence. People communicate using narrative, right? Think of movies, novels, or sitcoms. Like even when I'm recounting my experience over here, right? We use narrative as humans. And so we thought it'd be really cool to train an AI agent which would understand narrative, right? So if there was an AI agent which could understand the notion of a story, we thought that might be really cool.
Yeah.
So we went ahead with this. We discussed this idea with our advisors, Devi Parikh and Dhruv Batra. They liked the idea. We also started talking to Mohit, who's the NLP expert. So we brainstormed a bunch of multimodal aspects. So how to simultaneously bring in aspects of vision as well as language to this problem. And I was intending to intern with Mohit at Toyota Technological Institute in Chicago in the summer. So everything sort of fell into place.
Yeah.
And we finished. Yeah, we finished the project in the first half of the summer, and we presented this at one of the primary NLP conferences. It's called EMNLP, or Empirical Methods in Natural Language Processing. So we presented this work recently over there.
Right.
Cool.
So the kind of there were these two high-level intuitions behind what Arjun was saying in terms of bringing this together from the language and vision perspective. So first of all, something very interesting, which is how to make AI systems more human-like, right? So if you think of AI systems today, they are impressive in various domains and tasks like image captioning, question answering, machine translation, and so on. But then there's the next step involved, right? They lack something very clearly, which is how to interact with these agents, right? So they lack things like common sense or human-like characteristics of emotion, personality, for example, humor, sarcasm, politeness, which I'll mention later. And then the second big high-level motivation was going deeper into the common sense aspect of this, because, I mean, common sense is not so common, right? As Voltaire said, a long time ago, I guess. But this is even more true for AI systems. So because most of the recent improvements in these AI and deep learning systems is because of very strong, interesting models that can leverage very big amounts of data and obviously the ever useful GPUs. But then the issue of common sense is still unwritten, right? Because precisely because it's common and for the same reason, it's not really mentioned explicitly in the text and data that we work on. So it's obvious to humans, but not to AI agents. For example, if I'm describing a story, then there's obviously a natural flow, right? Like Arjun mentioned. And that makes the story coherent. And also sometimes it involves a lot of cultural and social norms. So this is kind of the overall creative AI aspect of this. And then these guys will now give you the technical meat of it.
Yeah, I think it's fascinating. I mean, yeah, you talk about common sense and how it's, it's something relatively, it's something that grows. And I was thinking of the cultural piece, and I know that certain cultures emphasize certain storytelling mechanics, and it's really fascinating you guys think about it in that way, because you're kind of laying some foundational work for how this might even think about it, which is
this is definitely more on the foundational side, exploratory side, and we'll say how we think this can go forward and how people can help here.
Cool. Yeah, so I'd love to hear more about kind of the technical pieces that you're talking about. Kind of take it one layer up now.
Okay. So Mohit was just talking about common sense and why it's important. So in this project, we're focusing on one aspect of common sense. We're trying to teach AI agents which event comes after which, and we're trying to we call this temporal common sense. For example, every morning we typically wake up, we brush our teeth, we grab some breakfast, we probably shower, and we head out to work, right? So this is a canonical series of events that happens. Actually, let me share a picture with you, right? So something else is typically what happens in a restaurant, right? So when we go to eat food, we go in first to the restaurant, we sit down at a table, and then the food arrives. We order drinks. Sorry, we order drinks first, and then we order food. Eventually, the food arrives. We eat the food. We get our check, and we leave. So in this project, we're trying to which event is likely to occur after which in each of these cases, right? And so there are different ways in which we can do this task. And our approach is similar to the picture sequencing task that's given to kindergarten kids. So you can probably see that picture on your slide, on your screen right now. And so the idea is, given a set of aligned image caption pairs, we want to train models that can sort these jumbled image captions into of coherent image captions, which together are in the temporally correct order and which together form a good story.
Mm-hmm.
So that's the overarching goal of our project, right? And the data here, the data that we use to perform this task is Microsoft Research's sequential image narrative dataset. So this is an interesting dataset. It has a number of stories, and each story has 5 images, and each image has an associated narrative-like caption. So in our case, we call a set of an image and a story as a story element, right? And most of these stories revolve around personal or social events like birthday parties, visits to the beach, carnivals, amusement parks, etc. That sort of stuff.
Right. So basically, one thing to note here is that we are sorting the story, we are jumbling the story first and then trying to sort it, right? So just to give the audience and you some background and previous work on this, is that there's definitely a lot of work, at least also very especially in the NLP side, on entailment, right? What event follows what event, what are the discourse structures when we do a conversation. Even recently in the multimodal and, vision and language side, there has been work that has used this Microsoft and other data sets to try to generate stories. So the specific thing that we did was we tried to jumble the story so that instead of predicting a missing frame inside a story or the next frame given the previous frames, we kind of took the extreme version where everything is jumbled. So you're not given any past to predict the future, or you're not given the context surroundings to predict the middle thing. You have to just generate the introduction, the middle stuff, the climax, everything. Right. So there is, just to be clear, like a lot of interesting groundwork done on this from both communities already. But this is the specific way in which we are doing this differently.
It's interesting you say that, because I've seen a lot of the visual pieces, and I've seen some really great progress. And you have this scene and you block out a tree, and does it figure out putting in a tree, and it feels like an accomplishment, but a different accomplishment than kind of what it seems.
So a lot of the pieces are like influential pieces have been done with great work before. This is kind of a higher level semantic understanding project.
Cool.
Yeah, so I think I can talk more about like how we built our models and what were the techniques involved in order to like get these results, right? So in order to predict like the correct temporal order of the image caption pairs, we tried 3 approaches. So the first one was fairly simple and straightforward, right? Train a model that takes an input, a story element, an image caption pair, and predicts the position of that element in the story from 1 to 5, right? And this approach although this approach has little context about the other elements present in the story, and only relies on that one element, it does pretty well. It turns out that the sentence alone has enough cues that the model predicts whether it occurs at the beginning of the story or occurs at the end of the story, right? Because from the sentence construction, you can figure out whether it's occurring at the beginning of the story or at the end of the story. Mm-hmm. So the next step was an obvious natural step where we tried to incorporate some context into the prediction. So we tried a pairwise approach in which, given a pair of image caption story elements, the model predicts which comes first. We do this for all pair of story elements and combine the scores to infer the correct order of the elements.
Sorry, Harsh, 1 second. So Chad, so we are also trying to show the model in the screen that Arjun is sharing.
Yep, and we're looking at it live with focus on it. So yeah,
Okay,
we should be
great.
good.
Yeah, okay.
Sorry.
No worries.
Yeah. So, so the second model, where it takes two inputs now, starts learning the notion of what comes first, and we'll see later in the qualitative examples that doing this captures the notion of a narrative really well. And in the third approach, we wanted to learn an approach where you're not doing this exhaustive inference. So in the third approach, we project the captions into a high dimensional space that has a special property. So as you move away, so think of it as an n-dimensional sphere, where as you move away from the origin, you traverse the story. So the things that occur in the story at the beginning will be closer to the origin than things that occur later in the story. So as you're traversing away radially outwards, you're sort of coming across the story. You're traversing through the story.
Interesting, yeah.
Right. And then, so how do we measure how well we are doing, right? So we measure the performance of our methods by comparing the predicted order against the ground truth ordering. So we compute correlation between these two. And then we also sort of look at other metrics like pairwise, like accuracy of pairwise predictions and the average displacement of the predicted position to the actual position in the story, right? And so we observe that pairwise obviously perform better than unary. This is not surprising since it has more context, right? And the best method is where where both the methods, the unary and the pairwise, vote towards the final prediction. And another important to note here is that using image plus text as input does better than just using captions. We don't use just images as input because by themselves, they don't mean anything, right? Only when we ground an image to a text can we tell a story.
Right.
And so we were looking at qualitative examples, and our intuition regarding why image plus text does better than text is that the image plus language model tries to set up the scene first. So most predictions tend to not have people in the first element of the story. The model tries to pick those images first that shows the bigger picture, and then puts the group photos and the celebration part later in the story. It also somewhat learned the notion of time. So visually, it's easier to see whether the scene is an outdoor scene versus an indoor scene, whether it's a morning scene versus a night scene. And that people tend to be outdoor in the morning and indoor in the evening, right? So this general notion of common sense of how people tend to live their daily lives is sort of captured using both images and text.
That's really interesting. It's I've noticed some similar things with other research about I can't remember the exact name of it, but they were looking at a bunch of different faces and they were kind of training it how to change faces, and it kind of learned the idea of glasses, and that glasses were a removable object, you know. And I think of that, it's like, oh, it's really fascinating that it would kind of start to learn this idea that, you know, at night we tend to be social, and at night, you know, that's really fascinating.
Right, and that you end outing with a group photo or desert comes later.
That's funny.
So Arjun will give us some nice actual examples.
Yeah, that's great.
Yeah, so we have a few qualitative examples. So while we're on the entire stories, I just wanted to show you this. So here are some examples of some incorrect predictions from our model. So the slide that you saw before were correctly predicted stories. And so in this case, we have incorrectly predicted stories, and this sort of shows you some of the challenges with this data, with this task. So you see the story on the first story on top, right? In this case, you have a number of events which are all very similar to each other, right? So it's really hard to tease apart what the temporal sequence of this would be because everything that's happening is just so similar, right? So in cases like these, it's very challenging. And in the second case, you have distinct events, but then there's no clear canonical temporal sequence in which these need to occur.
Right.
So this is
especially in the second one, yes. You can see that if you swap some of these, then also it would still make sense, right? As opposed to Arjun, if you go back to the previous slide once, in the correct predictions, you can see that the first one as a party, you know that you start with the food pictures maybe, and then people coming in, and then taking turns to write something. So that one makes sense, right? If you swap something, then it would be something would be amiss.
Mm-hmm.
And similarly, in the day outing, right, when you go out and then it ends with fireworks usually and dessert.
Right. And I think, I mean, are you kind of suggesting as well that in the second example, the slide 9, that some of those things in real life, even for our common sense, it would be difficult for a regular person to be have any idea between them?
That's exactly what we meant. Like if I showed you a swap story and showed you one story, the one shown here, and one with some frame swapped, and asked you which one is the correct order, even humans would have a hard time.
Right.
Yeah,
cool.
And this also sort of shows why images by themselves don't mean anything, right? Because like I could erase the text and then give you some order of the images, and you would be able to visualize a story for that.
Right.
So for these complex cases, the captions help a lot. Right?
Yeah.
But overall, the image plus text model does do better than text alone, which was a cool kind of result. And then Harsh had some examples of specifically where the image plus text model does better. And then you can imagine things like Harsh said, where things like something starts when it's morning and then ends at night, which is very visual.
Right.
Okay. And then Arjun, you had some cool.
So I have some other interesting observations. So if you look at this confusion matrix over here, so this sort of shows how our model learns the introduction, the setup, and the climax portions of a story. So it's called the 3-part structure of a story, and most stories can be divided into these 3 parts. If you look at this confusion matrix, this is a result from our unary model. So which means this model, given one image and caption, it predicts the position in which this image caption pair occurs in the story, right? Now, if you look at the diagonal of this confusion matrix, you can see that the diagonal is darker than the rest of the squares, right? And so this is because our model predicts these more accurately than the rest. Now, if you look at the top left and bottom right, these are darker than the rest of the confusion matrix, because our model has no problem, or it is more accurate in predicting the positions of the first element and the last element. So it clearly understands which image and caption occurs in the beginning of the story and the end of the story. And you can see that the middle portion is sort of confusing. All of these are sort of lighter than the rest because our model is confused about what events happen in the middle part of the story. And so we can look at the text from the captions. So in this case, this picture shows the discriminative words in each position of the story. So these are words from the captions, and the size of these words show how likely this word is to occur in that specific position. And this is what our model believes. So if you look at this picture, that the first picture on the top left, so you have words like friend, Halloween, party, location, today, and that sort of stuff. Yeah, and so this is, and you look at locations or events, and this is sort of like the introduction to the story, where people say what's going to happen through the story. It's like, we went to this location, today we celebrate Halloween, we are meeting with friends, that sort of thing. And so this clearly shows that our model understands the story introduction. Now, if you look at the second, third, and fourth captions, or the words that belong in this caption, they all seem sort of similar. They're talking about peoples or friends in general.
Right.
So there's no clear distinction here. But then if you look at the last caption, or words from the last caption, you see stuff like great, ended, night, home,
afterwards,
everybody, afterwards. So all of this is indicative that the evening is over and people are heading back home. And so this sort of shows, or it's one way to visualize how our model has learned the 3-part structure in a story.
That's really cool. Yeah, it's fascinating to see that the actual, some of those words really in the 2, 3, 4 range of some of that more general language. That's fascinating.
Right. Yeah. And as humans, that's true too, right? We know how, the beginning and the end are more kind of concrete, but then you can arrange the rest of the day in whatever way you want when you decide a party.
I think about my day really. It's it's breakfast, like waking up, and then it's probably lunch orientation. What are we doing for lunch, and then dinner, and what I did between those periods, who knows?
Exactly.
Yeah. That's pretty cool. One question that was coming to my mind is like, what language did you program in? Did you do this in Python? Like, what did we actually code? A lot of my audience is programmers, and I would love to kind of like, what did you actually code it in?
So we used a deep learning framework called Torch, which is in Lua, and like Torch is now Torch is mainly maintained by people at Facebook. So it's fairly exhaustive. You can almost do any sort of thing that you want to do with deep learning in Lua, and then you sort of build your models in Lua, and then a lot of like the pre-processing and the post-processing and the visualizations happen in Python. Yeah, so like it's a mix of both, where you're sort of getting the data and processing it to feed into models using Python, and then you train the models using
exactly.
Torch and Lua. Yeah.
And that's most of I think you will listen or like hear this for most our deep learning AI projects these days. It's one of like these big libraries, either Torch or TensorFlow, or I mean Theano also is one of the popular options. And then all of these are usually Python based, but then you want the wrappers around them, which are also then Python mostly.
Yeah, that's cool. That's fascinating. So thank you for taking me through that. It's really cool because I read your paper, and then obviously you kind of have a lot more questions, and it's amazing how much life you guys are able to kind of breathe into it by explaining it. So I think it really helps the comprehension. So I appreciate that. Let me take a moment to say that this wouldn't be possible without companies like Amazon.com. If you have experience with machine learning and are looking for a new challenge, they have over 100 opportunities available. Be sure to check out the link in the description, and let's get back to the show. I'd love to, what are some potential applications of this type of stuff that you guys would see kind of going forward?
Right. So one application is where we can do multimodal, multi-document summarization. Right. So right now we have a lot of information that lives online. We consume a lot of data from social media websites, for example, and these are essentially multiple sources of information where different people post their own takes on the event or an entire story, right? And one application is, if we can take these multiple sources of information and we can collate them, we can sort these into the temporally correct sequence, and we can post it as an entire coherent story. Right? So that's one application.
Right. I think sorry, I just wanted to mention these yearly summaries that are popping up on social media, right? Here's your yearly summary. So imagine doing this for just in the wild, right? When you don't have timestamps on your pictures, or it's not just coming from the same source and your own profile. Suppose you have a bunch of friends sharing their pictures from random phones and random laptops, and just they don't remember what this is, and you want to create a wholesome kind of life summary of their shared friendship together.
Yeah,
so that's one kind of.
I'm a big Google Photos user, and I think Google Photos does a really great job of classifying people and whatnot. But yeah, I mean, it could actually put together a full narrative of saying like, hey, this was actually the full thing. And it tries, right? It grabs like random few photos and uses some timestamps. But yeah, that's an interesting application. Yeah.
Right. So the other application is probably something like question answering, right? So we ask an AI agent about some news story, right? So what if we ask, what happened after the police arrived, or something like that? So we need this agent to be able to reason about what the chain of events were, what sequences these events happened in, and answer only the part that comes after or before or in between some time period.
Yeah. And sorry to cut you off on that. So you talked about timestamps and not necessarily needing them, right? You kind of took the more difficult challenge. I would assume that building a model that included the timestamps could actually be helpful. So you talk about what happened after the police arrived, and you think about Google News and being able to aggregate 50 news stories, and then applying your guys' kind of algorithm on top of timestamps might enable you to kind of have a different layer of context.
Yeah, no, definitely. That's a simpler kind of a subset problem of our more general application.
Yeah.
So if you have timestamps, then it's still useful, because then it starts looking at the more contextual, like semantic information.
Right. And also, so in my very little experience in industry, I've realized that timestamps are super noisy anyways, because if a timestamp is associated, let's say, with an image, then you don't know what that timestamp is, right? So you don't know whether the timestamp is associated with when the picture was actually captured, or when it was saved in the disk, or when it was posted, right? So you don't know this timestamp, and therefore it's super noisy. And sometimes, like if you're capturing photos from your phones, they would be null.
Right.
So you won't really know. So it
That's
sort of
interesting.
helps.
Yeah, that's a good point.
Yeah.
Cool.
Right.
And then there's also we have some other like interesting applications. So basically, Arjun, you have some more.
Yeah, I was just going to say that. So my personal motivation in this entire space is just because I think this kind of knowledge would help make AI human interactions more seamless. So that's sort of my main interest in this area. So say a human has to give an instruction to an AI, or multiple humans give a single AI system a series of instructions, and it has to somehow understand which order it should do this in, what sequence it should do this in, or people are narrating stories to this AI, essentially for AI to understand narrative as humans do. That's sort of
this gets into this gets into a big aspect of another application, which is generation of language. So we work a lot in my group on generating human-like language, and language that is that has common sense in it, right? So if you imagine generating stories for tutoring or for creative AI, right? And then suppose you're given an instruction or in language and you want to create a video trailer or a video summary of it. So then basically knowing what event comes after what. And this is also very important in just general dialogue models. When you're trying to predict the next response in some of the work in my group, you want to know like what event happens after what, so that you can create a coherent response to this, right? And we have some other work on summarizing big databases of events. So it can be a big database of weather forecasting events or soccer events, and you have to create a concise summary of kind of commentary on the weather forecasting or the soccer commentary. So first you need to not just choose the salient events, but you also need to order them, because these databases many times are just a big bunch of events with no order in them.
Yeah, it's like the big data part of it is becoming so crazy, and we are very fast and capable of collecting data, and now digging through it is becoming a new phase. By the way, you mentioned creating languages. Have you guys seen Arrival? What was your take on that? If you're thinking about artificial intelligence, I mean, did you like the movie?
I like the movie. Overall, I mean, I don't think they were trying to obviously add tons of linguistics aspects to it. There's been some very nice blogs from senior linguistics professors on this, but I think the overall idea of just a non-linear and kind of this whole concept of this radial language, I like that part.
I
think it got people thinking. That's the best part. I mean, it doesn't have to be it doesn't need to have closure and all the kind of no loose threads. I think the overall kind of idea was very cool.
Cool. So what are you guys up to next? And is there anything that our audience can kind of be helpful with?
Yeah. So I think, like I was mentioning in this previous question about applications, so one major kind of holy grail going forward is generating language. So as you know, most, if not all, big players are interested in like generating conversational agents and dialogue bots. So this is something, like I was saying, is very important from our project's perspective, where you can use models that know about temporal common sense to generate a coherent answer, not just for the current question, but understanding all of the previous conversation history. And so basically, this is what some of the work that's going on in my group, where we are trying to use temporal common sense and entailment knowledge to improve generation tasks like video captioning, video question answering, database summarization. And the other big aspect that we are working on is human-like language generation, which has emotions and personality. So that's another like kind of futuristic goal, because it gets more and more important for applications like trustworthy agents that are natural, right, in healthcare or tutoring, like for kids. So on that aspect, one of my students last NACL conference had this paper on understanding and explaining what makes language polite or rude. So So that's one very interesting kind of personality trait that we brought into language in terms of talking more naturally. And now she's extending that work to not just explain why language is polite or rude, but be able to generate polite or rude language as a response in a dialogue model. And then finally, Arjun and Devi, Dhruv, and I collaborate on another personality aspect called humor. So we had a couple of projects on this. One was at CVPR on understanding and modifying scene-based humor. And then the second project, which was the second project that Arjun did with me at TTI for the internship, was on generating funny captions. So not just a regular caption or description of an image, but can we twist it to contain some funny elements like maybe a pun. Mm-hmm. So Arjun will describe a little bit of detail about these two projects maybe.
Cool.
Right, so in our first project, we tried to understand and predict visual humor. So that is humor that is manifested in images, in static images, right? So we did this with abstract cartoon-like scenes. So mainly we were trying to do two things. We were trying to train an agent to first, given a scene, predict how funny the scene is. And secondly, given a scene, try to change the scene somehow to make it either more funny or less funny, so make the scene boring. So those are sort of the two tasks that we took on. And this was the project that we submitted that was published at CVPR. And so right now, again, we're working on humor. And this is as Mohit mentioned, it is to describe an image in a funny way. And the specific way in which we're trying to do this is to introduce puns, because essentially there are multiple ways in which you can do this. So using puns is sort of our best shot at this. And so to give you an example, like think of an image which, say, has a wedding. Right, so think of an image where there's a wedding, there's a large cake, and people around it are really emotional. And ideally, we'd like the caption to say, "The cake is in tears."
Yeah.
Or tears.
Sometimes you have to spell it out. so humor is also like common sense. It's not really
right.
Yeah, cool. I have another good one. I think we had this other good one where suppose someone is stealing something from your pocket, and the cop is standing right there. So then this person is a man or woman of steel. So STEA, because they have guts and they're stealing.
Oh man, the internet. if we get AIs that are dropping puns, I think half of Reddit will lose their job. So
yeah, we are getting there. I think we just had a meeting about this yesterday, and we are getting some nice results. And it's very challenging, because it's not that you can just take a word from the caption of the image and replace it with its pun. You have to make sure that after replacing it with its pun, or similar sounding word with a different meaning, you have to still maintain the meaning, the relevance to the image, right? So the semantic connection to the image is the hardest part.
Yeah, so that's interesting. Yeah.
Right, so that's why we have to use these generation models that not only generate conditioned on the image content, but also are kind of have a high probability of using certain pun words. So it has to be a delicate balance of these two things.
Yeah, that's cool.
And well, I think, I graduated after this project, after 2 wonderful years. So now I'm a research engineer at Snapchat. And without saying much, I think being a camera company seems like a pretty decent place for a computer vision researcher to work.
Yeah.
So you're doing the real work.
I'm getting AI to work, actually.
No, I think a lot of companies are doing a lot of interesting things, and I think Snapchat is a fantastic spot to do it. And I'm super excited about their ambition with spectacles. And my wife has been checking the spectacle location drop every 6 hours or whatever it is. And so
it's been very inspiring, like all that work.
Yeah, and then
and we need more and more I guess big components, right? Like more and more options, more and more companies doing big things. So that's the best part.
And I think Snapchat does a great job at building stories and telling a broader narrative. And I think it's super fascinating.
I think, like in hindsight, some of the inspiration for this work actually, I think, came up when I was interviewing at Snapchat, and we were just like talking about things we can do.
Yeah, that's cool. That's cool. Yeah. Cool. So like 30 seconds, a minute, I don't really particularly care, but anything you want to talk about, rant about, I don't care, but I call it the 30-second soapbox.
Yeah, so actually, in connection to that, I think you also mentioned that we would like to explain how the community can help us, if at all.
Of course.
So
Yeah.
we had a couple of, I think Arjun wanted to say something on that, right?
Yeah, so yeah, it would be great if people could read our paper and give us feedback about our method, our models. It would be nice if you could cite our paper.
Cool.
Yeah, so we're always
we
looking
have
for
more serious requests.
And I think like as a practitioner and as somebody who's interested in open source, I feel like we should also sort of encourage readers to learn more about AI and like how like all this deep learning and computer vision can help make human lives better. And like with deep learning, I feel like it has made the barrier to entry in this field really, really low, because like it's all about cloning an open source GitHub project and all the other tools are open source. So like start by cloning it, make tiny changes to it. And that's how like we learned to like build these fancy models. So yeah, I think it would be great if we can have more people do more deep learning in AI.
Right.
Yeah,
so use our models and use our data sets and the Microsoft data set, and also point us to new data sets that we are missing or things that we could apply similar ideas to. Basically, tell us what suggestions you have to improve it. And then, sorry, Arjun, go ahead.
So staying on this thought, Harsh mentioned how it's easy for people to get into AI right now. So I'm also interested in the impact that AI has on people's lives, right? How is AI impacting people's everyday lives? Because I think as AI engineers or scientists, as people who are developing these systems, it's really important for us to understand what kind of impact we're having on society. Positive impact, it's great to hear about that. Negative impact, it's important to hear about it. So I think it's important for us to understand what kind of impact we're having, and I'll be really glad if people could talk to us about how AI is helping and how it can help impact society better.
Okay, and then you asked for like a kind of a soapbox, but we'll treat it more like a kind of a conclusion and kind of like the plead is that overall, like I think as this podcast is about, we would want to like more and more people to work on creative AI. Because that makes it more realistic and useful for real life applications. Because, like I said before, it makes it more natural, has effective interactions with humans. And this is very important as we move more and more towards healthcare agents, right? Where in old age homes or for tutoring of kids, you need natural, effective, trustworthy interactions. And then also in general, like Harsh was saying, these AI and deep learning systems are easier to use these days. So please go use them. They are very good for specific domains and applications right now, but there's also a lot of interest in making them more general across domains, working out of the box. So we as a community are obviously making a lot of progress in this, but we need more and more people because they're obviously far from perfect. So yeah, we encourage diverse participation from everyone and kind of and are very open to suggestions for improvements and ideas. Thanks.
That's awesome. Thanks, guys. And I appreciate you guys joining me and kind of going through this. I found it, like I said, really interesting. And I wish you the best with doing the pun stuff. I think that super interesting. And humor is really hard, I think, even for the funniest of people. And so being able to replicate that with artificial intelligence is a tall order, but I think an ambitious and a good one.
Yeah, we'll send you, I think we should be submitting this maybe within the month. So we'll definitely send you a copy.
Great. Cool.
Hopefully it makes you laugh.
All right. Thanks, guys. Have a good one.
Yes. Thank you.